Hey guys, here is our video on lesson 5.4, reflections. Okay. If we put, this is on page 328 in your textbook. If we go into our calculator and let's just look at these first two functions. Clear. Okay. So 2 caret x and negative parenthesis 2 to the x. There. Okay. So let's look at what's the difference between these two functions. Okay. The difference is that this is my original function. My new function has a negative sign. It is negating, that's a verb, negating the entire function. Let's see what that does. Okay, so the blue one, that's my original function, 2 to the x power, and the red one is negative 2 to the x power. So what happened here? Well, if you remember back to reflections from 8th grade math, we essentially reflected the function over the x-axis. Okay, so let's make a note of that. If you negate the function, okay, you reflect over the x-axis, which is also referred to as the line y equals 0. Okay. Now I want to have you put in h of x and n of x into your calculator. What's the difference here? Okay, what's the difference between these two things? Well, the difference here is I've put a negative sign only in front of the x. And what happens? Okay, so what happened is now we have the original function in blue and this new function in red, and it's a reflection over the y-axis. Okay, so all my writing had to go away because I had to clear it so we didn't have to get it in the way. So if we negate the x, we have a reflection over the y-axis, which is the same thing as x equals 0. Alright, number 1 says write these functions in terms of the basic function h of x. So m of x is like taking h of x and the negative of it, like just sticking a negative sign in front of it. N of x is, well, not f. Such a habit to write f of x. Is taking h of negative x. So the difference is negate the whole function, negate just the x. Okay? Now we're going to come to this table right here. what I want you to do in your calculator, hold on a second. There we go. What I want you to do in your calculator is go into your y equals, have this be y1, 2 to the x, y2, and y3. And I want you to look at the table. Now, you'll notice that the table is already done for and written in coordinate form for y1, for h of x. What we're going to do now is fill in the blanks on this chart. And the point of that is we want to see what changes as far as x's and y's so that we can figure out coordinate notation. Okay, so for m of x, that's the red function here in the middle. I'm given the x value of -2, the y value is -0.25. -1 is -0.5, 0 is -1, 1 and -2, 2 and -4. Okay, and then we're out of them. And what I want you to look at is how do the coordinates compare? Like this is +2, +4. This is +2, -4. What changes coordinate-wise from one to the next? Okay, so in other words, if this xy represents these coordinates in that first column, how did those coordinates change? Well, the x values all stayed the same, -2, -1, 0, 1, and 2. Same x value. So x stays the same. But the y value goes from a 4 to a -4, 2, -2, 1, -1. So what happens is the y is negated. Same x and opposite sign of y. Okay? Now for this last one, they're giving us the y value, and we want to go back and find the matching x value. Nope. So they're showing a +1/4 y value. So I got to come over here to the y's and find +1/4. Well, it's written in decimal form, but it's right here, 0.25. And the x value there is +2. So I'm going to put that on the line. This is saying 1/2, which remember is 0.5. So I will look over here. 0.5 is the y value. What's the x value? That's 1. +1. Well, what's the x value? 0. +2, what's the x value? -1. And 4, the x value is -2. So when we are doing a reflection, let's go back and write what these are. If we're negating the whole function, okay, that's reflect over the x-axis, or we could also say it's reflecting over y equals 0. When we're negating just the x, that's reflect over the y-axis. Which is the same as y equals 0. Okay, so what's happening here with our coordinates? Okay, look back at your original column. I have 2, 4 at the bottom row, and now I have -2, 4. So the y stays the same, but the x switches signs. Okay, putting a negative sign in front of something doesn't necessarily mean it's negative. If it was negative to start with, I'd switch it to being positive. So be cautious of that. Negative in front of something means switch signs. Okay. Now, a lot of this information that I've given you is condensed in this. Oh, good, we're still recording. This handout right here. Okay? Reflections. The only thing I want you to add to this right now is it says reflection over the y-axis. Remember, that also means the line of x equals 0. So we're going to put that on there. Okay? Only the x is negated. For example, if f of x is 2 to the x is the original function, then g of x means f of negative x, which is the same as g of x equaling 2 to the negative x power. Coordinates will have the x values change, but the y's stay the same. And then it gives you an example of a point. So 2, 4 is a point in here that is on this graph, and its image point is negative 2, 4. Reflection over the x-axis. Remember, that means the same thing as y equals 0. Okay? The entire function is negated. So, for example, if f of x equals 2 to the x power is the original function, then g of x equals negative f of x, which is the same thing as negative 2 to the x power. The coordinates here, in this case, the y gets the negative sign. Okay, so there's a lot of details here, guys, and I want to stress that this is not something you're just going to magically remember because you attended class and did the homework assignment. This sheet I took the time to make for you with the intention that you're going to study from it. It has a lot of information on it. You should use it for studying. You should have this out while you're working on the homework for 5-4. If you're not my student and you don't have this, and you're here at Ernie Davis Academy, stop up. I'll print you one. Not a big deal. Okay? All right. For the rest of this, we're going to use this reference sheet to help us, but we're going to go right to the homework from here. In the first section, you're going to answer in one of two ways. What you're doing is writing things in terms of f of x. So you're either writing g of x equals negative f of x, or you're writing g of x equals f of negative x. What it depends on is where's the negative sign. If it's in front of the entire function, then it's in front of the f of x. If it's in front of just the x, then it's in front of just the x. Okay, so that's that section. Look at where did the negative sign appear. In the next section, you're going to do the coordinate notation and you're going to say what kind of reflection it is. Here again, I'm going to encourage you to use this sheet. It has this information on it. Where'd we go? Here we go. Okay, so what I'm seeing is that just the x has a negative sign. When just the x has the negative sign, that means my x is going to be negated in the coordinate rule. And it tells me that g of x is a reflection over the y-axis, or you can say x equals 0. I tend to write both because it's good practice to remember that they are the same thing. Going back to the original example problem they give you already done, they've negated the entire function. Negating the function means negating the y for coordinate notation. and it's a reflection over the x-axis, which is the same thing as y equals 0. I want you to write all these words. Okay, they say about y equals 0. We say over. Doesn't matter about the words. In algebra, we only do reflections over the axes. In geometry, you may be doing reflections over Hazy-Vixen type lines like x equals 5 and y equals -2. You'll also be doing reflections and stuff over a line like y equals x. So, you know, there's different types of reflections. We just don't get as deep into them in this course as you might in geometry. Alright, in this next section, they give you the original function and they want you to decide what kind of reflection that it is. So I see a negative sign out in front of the entire function. That means, and I want you to write this even though they don't in the example question, I want you to practice making yourself write the words as a form of studying and rehearsal and remembering how to do this. Reflection over x-axis. And now, how did they achieve this blue line? Okay, well, they kind of find points where the graph naturally crosses a coordinate pair, and probably one out here too. And if we're reflecting over the x-axis, one strategy I could give you would be to use a highlighter and highlight that. It will naturally draw your eyes to help you into drawing what you're supposed to draw. So if I know that I'm reflecting over the x-axis, that means I'm going to pick these dots that I drew and I'm going to count how many squares to get to that x-axis. So it took me 1, 2, 3, 4 squares. 1, 2, 3, 4 squares. 1 square, 1 square. Okay. And, you know, here where the asymptote is, the graphs are going to largely, they're going to appear to overlap. But remember that one graph is above the x-axis and one is below. It's not going to look like that, especially on your calculator. You'll see one, it'll look like there's one right on top of the other, but that's because we don't have the screen resolution on our calculators to make it look any different. And the values are so small that it would be really hard to see anyway. Okay, so next one says g of x equals f of negative x. Only the x is negated. So that means reflection over the y-axis, which is x equals 0. So highlight your axis. And find a couple spots where I feel like the graph naturally crosses. Okay. Then, let's see. This blue dot is 1, 2 squares away from the y-axis, so 1, 2 squares on the other side. The blue dot is 1 square away, 1 square away. The y-intercepts in this case are going to overlap. They're going to be the exact same point. 1, 2, 3, 1, 2, 3. And now we have enough dots to, that was drawn kind of bad. Draw our reflection in. But I want to see some evidence of dots, guys. Otherwise, you're just kind of eyeballing it. I don't want you eyeballing it. I want you to understand how reflections work. All right, in our next section, it says write a function g of x based on the clue that they're giving you. So guys, you're either putting a negative sign in front of the entire function, or you are putting a negative sign in front of the x. You have to know which it is. Okay? So number 19 said reflection about the horizontal line y equals 0. Remember, that's x-axis. So if we're reflecting over the x-axis, that means the entire function gets negated, gets a negative sign. If we're reflecting over x equals 0, that's the y-axis, that means I'm going to stick a negative sign only in front of the x. Okay. Now, down here, say 24. No, I lied. Where do I want to do? Okay. Reflection about the horizontal line y equals 23 is the one I'm looking at right now. That's x-axis. X-axis means the entire function gets negated. So I'm going to take 2 to the x plus 9, put it in parentheses, and negate it. That's how you show with notation how to negate a function. You can just put a negative sign in front of it. Now you could distribute the negative and say negative 2 to the x minus 9, but honestly leaving it that way is fine. This next section, what they don't do, but I'm going to make you do, is they only show drawing the reflection. What I want you to do is draw both functions. I want you to draw, 5 to the x power so original function, -2 0 1 1 5 2 25 doesn't fit, but I got enough points here I can see the curve. Okay, I want you to draw the original function. Then it tells you what you're doing. You're reflecting over the line y equals 0, which is the x-axis. They want you to draw the picture, so I'd be taking these dots that I drew and going toward the correct axis. Okay, 1 2 3 4 5, 1 2 3 4 5, 1 1, and then the rest of these are pretty close. Okay, I want you to draw both. Okay, then write the function. If it's a reflection over the x-axis, you're negating the entire function. So the next homework 126. All right, same graph, 5 to the x power. So I'm going to draw the original. And then it says, oh, sugar, I cut it off. X equals 0. Let me see if it'll let me move my, hey, there we go. Okay. X equals 0 means y-axis. So my g of x, if I'm reflecting over the y-axis, means 5 to the negative x, means I'm negating the x. I'm reflecting over the y-axis. So 1 square, 1 square. Stays right on there. 1 square, 1 square. Okay, so you should have 2 functions drawn on every graph, even though your example problem only showed 1. Okay, the next section, they're asking you to write what in words what happened. It's a reflection over what line. That's all they're asking you to do. Now they got into some crazy stuff here. 33, 34. Okay. These are not reflections. They've mixed in a couple other things. So this would be a translation. Okay, looks like 1, 2, 3, 4, 5 units up. So they threw in a couple of those just to mess with you. And this last section is, again, asking you to look, where's the negative sign? Oh, it's in front of, in 38, it's in front of just the x. So we would say that this is a reflection over the y-axis, which is x equals 0. Okay? So that's all you're doing, is telling it's a reflection over which axis. And how do you know? Look for the negative. If it's just in front of the x, then it is a reflection over the y-axis. If it is in front of the whole function, it's a reflection over the x-axis. And here again, they threw in some stuff just to mess with you. For example, look at here. I have a -5. Whoops, that's eraser. I wanted highlighter. I have a -5 here. And it's -5 to the whole thing. So this would be translation 5 units down. So they're being tricky with you and throwing in some things from 5, 3. Oh, Miss Andrews, I don't remember that stuff. Well, again, you have this sheet that I made you that has all the translation stuff on it. Okay? So if you don't remember and they've thrown some things in there, make sure you look at this sheet. Okay? Have a great day, and I'll see you next time.